Hi. So now I'm going to talk about Real Time ETL, and this is the backbone actually of any real-time data warehousing system. So we'll see what kind of solutions are available to us in terms of real-time ETL. So one of the most difficult parts of building any data warehouse is the process of extracting, transformation, cleansing, and loading ETL, as we call it, from the source system. So this consumes, as we know, almost like 70 to 80% of the project time. And performing ETL of data in real time introduces additional challenges, as we've seen, right? And almost all ETL tools and systems, whether based on off-the-shelf products or custom coded, operate in batch mode. So basically, that is you run the ETL in a batch mode and forget it, and it will be done in some time. And they assume that the data becomes available as some sort of extract file on a certain schedule, usually nightly, weekly, or monthly. Then the system transforms and cleanses the data and loads it into the warehouse. So this has been the traditional way we have been doing ETL. So when loading data continuously in real time, there cannot be any system downtime. So when you want to load data into the data warehouse in real time, there cannot be any system downtime, because then if as the data is being generated and you're loading, so the system would always be down. And it may be possible that the heaviest periods in terms of data warehouse usage coincides with the peak periods of incoming data. So that is also possible. So the requirements for continuous updates with no data warehouse downtime are generally inconsistent with the traditional ETL tools and systems. So that means continuously updating the database or the data warehouse, and no downtime cannot be achieved with the traditional ETL tools. Fortunately, there are new tools on the market that specialize in real-time ETL and data loading. And there are also ways of modifying existing ETL systems to perform real-time or near real-time data loading. And ETL systems, as we have seen, has a very clear boundary where dimensionally prepared data is handed over to the front room, or to the data warehouse, or presentation servers, as we call them. A real-time system cannot have this boundary. Architecture of front-end tools is also affected at the same time, right? So like three data delivery paradigms that require end-to-end perspective from original source to user screens are like alerts. I have talked about this in the first lecture on real-time data warehousing, continuous polling, and non-event notification. So these are some of the things that we need to have. These kind of applications are important, and let us see some details about these. So alerts are data condition at the source forces an update to occur at the user screen in real time. So these are alerts. These could be any kind of alerts, right, about a fraud or about a suspicious activity or any such thing. Then there is something called as continuous polling. The end user's application continuously probes the source data in order to update the user screen in real time. So they basically keep probing the source data in real time, and they keep updating the user screen. And then we have non-event notification. So the end user is notified if a specific event does not occur within the time interval, or as the result of a specific condition. So sometimes you expect some events to happen, and when they don't happen, you need a kind of a notification, or you can say an alert, right, saying that this particular event did not happen, right? So there can be many situations where you can expect this non-event notification as well. Alerts are basically for an event, and non-event notification is for a non-event, like that is the event did not happen, although functionally these are both same, like they all would both would lead to a kind of a information on their screens. So so I'm trying to put forward some of the difficulties from different perspectives, right? So I'm trying to give you introduce you to the challenges that are faced when we try to work with a real-time system, and especially when we are talking in terms of real-time ETL, because ETL in itself is a very, very complex process. Tool that moves data asynchronously into a data warehouse with some urgency within minutes of execution of the business transaction. Real-time data warehousing demands a different approach to ETL method used in batch-oriented data warehouse, and running ETL batches more frequently is not practical to OLTP or to data warehouse, right? And we'll talk about this in a different context. So if you plan it properly, right, or if you handle it properly, then this could be a solution for near real-time systems. So in the next few slides we'll discuss this point again. Including the data warehouse in the commit logic of transactions doesn't work either, because what happens because of this that the transaction itself gets delayed, and also locking the tables involved and the two-phase commit, so which are used for handling deadlocks, so they also don't work because of different structures and granularity in different systems. So these are all challenges that a real-time ETL tool would face. So the main challenge in RTDWH real-time data warehousing is to bring integrated and transformed data with zero or almost zero latency to the data warehouse, and role of ETL tool thus becomes critical. So let us see. So we first talk about a solution which is not real time, but it is near real time and may suit certain kinds of applications. So simply increasing the frequency of the existing data load may be sufficient if handled properly. So we'll talk about this handling part. A data load that currently occurs weekly can perhaps be performed instead daily or twice a day. A daily data load could be converted to an hourly data load, and for this we use a technique or an approach called as trick and flip approach. While not real time, near real time may be a good inexpensive first step. So basically you have a traditional or the conventional data warehouse, and your objective is to have a real time data warehouse, right? So it is not a bad idea to have a near real time data warehousing solution which is less expensive. And this solution is very expensive. So it's a kind of a compromise in terms of the real-time aspect or the latency aspect or the urgency aspect, but at the same time it is less expensive, right? So trickle and flip. So let us now focus on trickle and flip and some related techniques which would help us build a real-time ETL. So the trickle and flip approach helps avert the scalability issues associated with querying tables that are being simultaneously updated. So instead of loading the data in real time into the actual data warehouse tables, the data is continuously fed into staging tables that are in the exact format as the target tables. So they have the same format as the target tables, and depending upon the data modeling approach being used, right? So we have used the, I've already discussed the real-time fact table partitions. The staging tables either contain a copy of just the data for the current day, or for smaller fact tables may contain a complete copy of all the historical data. So we introduce some tables in the staging area which are identical to the in structure to the fact tables that we are talking about, and it can either contain only the current day's data. So if I'm talking about a daily granularity or a daily refresh or daily batch process, so it contains only the data for the day, or for smaller fact tables for right which are there in the data warehouse, this could contain a complete copy of all historical data. So then on a periodic basis, the staging table is duplicated and the copy is swapped with the fact table to bring the data warehouse instantly up to date. So to make the data warehouse instantly up to date. So if the integrating real-time partitions if the integrated real-time partition through views approach is being used, this operation may simply consist of changing the view definition to include the updated table instead of the old table. So integrated real-time partition through views approach. So I'll talk about this, right? So where there we would need only, so there is this so there is this fact table, and there is this kind of, as I told you earlier, so we have this real-time partition, so we can hide this into a view. So that I've already discussed in the previous lecture. So depending on the characteristic of how this swap is handled by the particular RDBMS, it might be advisable to temporarily pause the OLAP server while this flip takes place, so that no new queries are initiated while the swap occurs. So so you see, so what you have, so there is a on a periodic basis the staging table is duplicated and the copy is swapped with the fact table to bring the data warehouse instantly up to date. So this is what is trickle and flip. So this approach can be used with cycle times ranging from hourly to every minute, and the best performance is achieved with 5 to 10 minute cycle, but 1 to 2 minute cycles or even faster are also possible for smaller data sets or with sufficient hardware, right? But it is recommended that you test it under full load before it is brought into production to find the cycle time that works best for the application. So if you say, if I just go back and talk about trick and flip again, so what we do is in the actual, so we don't load the data in the actual data warehouse tables, and but we put them in the staging tables that have the exact format, right? And these tables can either contain only the current data, and if possible for smaller fact tables they can contain the historical data as well. So this is what is trick and flip. Then we have another solution called as the external real-time data cache. So all of the solutions discussed so far involve the data warehouse's underlying database taking on a lot of additional load to deal with the incoming real-time data and making it available to data warehouse users. So the best option in many cases is to store the real-time data in an external real-time data cache. We call it the RTDC, right? Outside the traditional data warehouse, completely avoiding any potential performance problems and leaving the existing data warehouse largely as is. So what we do is we externally create a table which we call as the real-time data cache, where we put the real-time data. So the real-time data cache can be simply another dedicated database server, or a separate instance of a large database system dedicated to loading, storing, and processing the real-time data. And applications that either deal with the large volumes of real-time data, like hundreds and thousands of changes per second, that kind of data, or those that require extremely fast query performance, might benefit from using an in-memory database for RTDC. That is, in-memory, that means where everything happens inside the memory. So in-memory databases are very popular for certain kinds of applications. And so your RTDC can be implemented on top of a in-memory database. So such in-memory databases are provided by, so there are lots of vendors like Angara and Cashflow and KX and many others. So you can try to do that. And the next point about RTDC is that regardless of the database that is used to hold the real-time data cache, its function remains the same. Function is that all real-time data is loaded into the cache as it arrives from the source systems. And depending upon the approach taken and the analytical tools being used, either all queries that involve the real-time data are directed to the RTDC, or the real-time data required to answer any particular query is seamlessly imaged to the regular data warehouse on a temporary basis to process the query. So you can see that either we can direct queries that involve real-time data to the RTDC, or the real-time data required to answer any particular query is seamlessly imaged to the regular data warehouse on a temporary basis to process the query. So that means I can put that data that is required for a regular query, which requires both aspects, the current and the historic. So it is seamlessly imaged to the regular data warehouse on a temporary basis to process the query. So there are solutions for this. So I'm going to talk about how we can do this. So, but before that, I'll talk about a little bit more about RTDC. So using an RTDC, there is no risk of introducing scalability or performance problems to the existing data warehouse, and which is particularly important when adding real-time data onto an existing data warehouse. Further, queries that access the real-time data will be extremely fast as they execute in their own environment separate from the existing data warehouse. And a good solution for users who need up to the second data typically don't want to wait too long for their queries to return. And also by using just-in-time data merging from the RTDC into the data warehouse, or reverse just-in-time merging from the data warehouse into the RTDCs, queries can access both the real-time and the historical data seamlessly. So in the previous slide, when I said seamlessly a query can access both kinds of data, so the solution for that is just-in-time merging or the reverse just-in-time merging, and these two techniques I'm going to discuss next. So RTDC and JIM, that is just-in-time merging. So there is a class of applications which tend to share two or more of the following characteristics. So you can see these characteristics. So require true real-time data, not real-time. So this is one thing. Involve rapidly changing data, that is 10 to 10,000 or 10 to 1,000 transactions per second, and need to be accessed by tens, hundreds, or thousands of concurrent users, and analyze real-time data in conjunction with historical information, and involve complex multipass analytical OLAP queries. So any class of application which requires two or more of the following, and for that we use a technique called as just-in-time merging and the reverse just-in-time merging. So these applications requires best aspects of a traditional data warehouse, such as access to large amounts of data, analytical depth, and massive scalability. and at the same time they also require access to real-time data and processing speed provided by a real-time data cache, that is RTDC. So necessary for such applications, it becomes necessary to use a hybrid approach. So the hybrid approach basically talks about real-time information. So it is about that the real-time information sits in the RTDC and the historical information sits in the data warehouse, and the two are efficiently linked together as needed. So this can be accomplished by an approach known as just-in-time information merging. A variant of JIM is reverse just-in-time data merging, so called as RJIM. So RJIM is useful for queries that are mainly based on real-time data, but that contain limited historical that require or contain limited historical information as well. So in RJIM, a similar process takes place, except the needed historical information is loaded from the data warehouse to the RTDC on a temporary basis. So basically, if you look at JIM and RJIM, so this is my RTDC and this is my data warehouse. So this is my RTDC, and so this I call as JIM, and RJIM is basically, again, you have two components, RTDC and the bigger data warehouse. So you can see in RJIM, so historical data is taken from the conventional data warehouse and put in the RTDC, whereas in JIM, this real-time data is taken from RTDC and put in the data warehouse. So that's the only difference. Okay, so in RJIM, a similar process takes place, except the needed historical information loaded from the data warehouse to the RTDC on a temporary basis, and then the query is run on the cache. This only works when the data cache is located in an RDBMS system with full SQL support, and will not work with some IMDB systems that do not support many SQL functions. Right, so IMDB, they may not support all kinds of SQL functions. So it is important that for JIM and RJIM to work, so you should have your data cache implemented in an RDBMS. And these are the references that I have used for this paper and for this presentation. And so we basically, in this lecture, we looked at three solutions. So one is near real time using trickle and flip, and then we use the concept of RTDC, that is real time data cache, and to support all kinds of queries, so we propose JIM and RJIM, right? Queries that require both historical as well as current data. So JIM and RJIM are proposed, that is just-in-time merging and reverse just-in-time merging. So with that, I wind up this lecture on real-time ETL tools or real-time ETL. And now we are left with only one article or one lecture on the role of ODS in real-time data warehousing. So that I'm going to do next.